the sine of theta, the sine values are those y coordinates we just talked about, right? The inputs to this equation would be angle measures, right? And we want to look at what the graph of this would look like. Okay, so I want to see if I can show you something that might make sense of this. So here we have here's the unit circle. Okay, we're calling the angle measure how much we've rotated theta, right? We've already talked about how the sine of theta. I know this font's kind of small, but the sine is equal to the opposite over hypotenuse, which is the y coordinate. So as we try to think about sine as a function and graphing the curve, the sine curve, which is something you've never thought about before, okay? What we're literally doing is we're saying that whatever the length of this side is for a certain angle, so whatever this says it's a 49-degree angle right now, okay? If my x coordinate is 49 degrees, I'm going to convert that to radians later, okay? Then the y coordinate should be whatever the height of this triangle is, right? The sine is the y, okay? So if I go back to what we were just talking about, these points we have. Could everyone real quickly draw a set of coordinate axes on your paper? Okay. So we're talking about something like this, okay, where this x-axis are angle measures, the y-axis are the sine values. Okay? Just to kind of anticipate what's happening. What we're saying, you guys, on everyone's paper in the room, I've walked around, you guys wrote a second ago that the sine of 0 equals 0. You guys ever made like a T-chart to plot points on a graph or something? Okay? If I think about doing that for this, right, I want to know what y values would be for different angle measures. So for when the angle is 0 degrees, the sine is 0, you all wrote. So that means there should be a point on my graph at 0, 0. Agree? Is that okay? If I'm going to jump down to 90 degrees. At 90 degrees, what did you write the sine was? 1. So the y coordinate is 1. So that means if I got over here to 90 degrees, there should be a point at 90 degrees, comma 1. Agree? And so on. I could keep plotting. At 180, where would the point be?
0.
0 again. I'm running out of room here. That's okay. Okay? Now, so the idea is those y coordinates should be plotted along my graph. So I'm going to let this computer do it for me because it'll do a better job. Okay? But the idea is I want you to look at the fact that this length, the height here, is equivalent to the height of the points that are being plotted. So if I stop this at any time, right, what this is doing is it's plotting a point a bunch of times for us, right? 0 degrees, 1 degree, 2 degrees, 3 degrees, 4 degrees. It's plotting all those points. And each time, where the y coordinate of that point is equal to the height on this triangle. Because the y coordinate is equal to sine. Okay? And if I keep going, maybe. Nope. Right, as I keep going, we're seeing the entire picture of this, what the graph of sine of theta looks like. Okay? Each one of those little red dots is 1 point. This graph for different angle measures. Right? We've got on our paper a handful of them. Okay? Now, notice that on this unit circle over here on the left, right, the amount of rotation that's gone by is this light blue curve, right? That's the degrees that it's rotated, and that's equivalent to the x-coordinate on my graph, right? So if my angle is a little bit more than 270, then I should be at a little more than 270 here. Now I labeled these as radians because I wasn't sure where you're at. We probably aren't there yet, right? Do we know that 3 pi over 2 is the same as 270? It's on the unit circle that you have on your sheet that I stole from you. Okay, so this is the picture of what a sine curve looks like. You guys have does it kind of make sense where this is coming from? Like why it's shaped this way? What we're literally doing is unraveling this unit circle, basically, right? All these heights are positive. What happens when my angle is more than 180 degrees? Okay, well, my opposite side is going down. What does that mean? It means I should have negative sine values. Okay, so if you could right now, without on your paper, what I'd like you to do is just is plot a few major points for me. So just to be clear about what's happening. Okay. Any function is just a set of ordered pairs, right, of points. Okay, so you've seen the big curve here. What I'd like for you to do is let's take your axes that you've drawn, and I want you on the x-axis to label every 90 degrees. So go from 90 to 180 to 270 to 360. And plot just the points for where the sine of theta should be. Okay? So the x is your angle measure, the y is the height or your y coordinate on your unit circle. And you don't even need to connect them yet. I just want so your graph should have also a 0. Okay? So your graph should just have 5 points on it. So, we're making some, great, thank you. So we have these points. We've already filled out on our little chart that, or whether it's a chart or not, we all have listed on our paper that the sine of 0 is 0. So 0 degrees, we have a y of 0. The sine of 90 is 1. So that means when x is 90 degrees, my y should be at 1. The sine of 180 is 0. So I should have a point where y is 0. The sine of 270 was -1. That was at the bottom of the unit circle. It was down. Okay? So I should have a point down here at -1. Okay? The sine of 360, we're back to where we started. We're at 0 degrees. So I should be back at 0. This matches what you saw in that little computer diagram. Okay? When you're connecting it, try to make it a little bit curvy, right? It comes from the unit circle. It's not just a mountain looking thing. Okay? So we've got 3 minutes, so to finish this up, I don't have anything printed out for you, but just in the last 3 minutes, I want to see if you can anticipate what would happen. What if I kept going? What if I went around another 90? What's 360 plus 90? It's 450 degrees. Could you anticipate if I add on your little thing here, add 90 a couple more times? So what if I have 450 and 540 and 630 and stop at 720? Plot where the points would be. You can picture going around the unit circle another time. So once you get to 360, you're starting over, basically, and I'm just continuing the same pattern. So this is just no stress if you don't know what's going on, just to kind of test where you're at with it. I'd like to have you kind of turn it in. How do you normally handle that? And that's not, it's probably not a good
We're
situation.
taking hand it in right here on the rail.